Good afternoon. My name is Sudhir Jain. As Kasha said, my colleague Ahmed was supposed to be here and make this presentation. He couldn't be here. I'm excited to be here with you, and I'm excited to share this novel additive manufacturing technology that NanoOPS is commercializing. It's particularly suited today for advanced packaging applications, interconnects, 3D heterogeneous integration, and we're working on advancing the technology capabilities to be able to build full functional circuits, and so stay tuned for that. As a matter of fact, I think Ahmed has a presentation in Berlin where he's going to talk about the work that we are doing now on semiconductor manufacturing using our technology. So my talk, I've sort of thought about dividing it into 4 parts. I'd like to introduce the technology, talk about some applications. We're very excited about a new product that we introduced a couple of years ago, which is semiconductor factory in a box. So like Winston talked about semiconductor factory in a box, our factory would be probably about the size of this stage that I'm standing on. And so I'll talk a little bit about that as to what its capabilities are and how people are using it. And after that, we can do any questions that you may have. So since we started talking about semiconductor factory in a box, essentially, I'll talk about the technology in a second, but what we did was we took this technology and put everything that is needed to build a functional circuit into a complete machine that, as I said, is the size of about this stage that can allow you to take a CAD file and be able to create a complete circuit out of it. The technology is, there's no compromise in terms of its feature size capabilities. As a matter of fact, the technology has been used to demonstrate, and I'll show you some samples of it, down to 25 nanometers. The semiconductor factory that we have, just like Winston talked about, it's not as capable as being able to do all of your IC circuits, but we can do feature sizes that are bigger than 300 nanometers in size in this particular machine. It is a wafer scale process, so our throughputs are similar to the throughputs that you have on wafer processing machines in semiconductor industry, except it's a purely additive manufacturing, so we don't have any etching. As a result, consequently, you get higher throughputs than you typically get in a semiconductor manufacturing process. It's certainly thousands of times faster than inkjet printing, which is typically what people talk about when they're doing additive manufacturing. So since we're on the subject of inkjet printing, maybe I can start by drawing a contrast between inkjet printing and NanoOPS technology. In a typical inkjet printing process, you have jets that are dropping droplets. In order to get a structure that's functional, you need to go through and add about 3 droplets in the same space to be able to create a nice feature size. What we are doing is not doing droplets. What we're doing is taking particles that are suspended in a bath and driving them, directing them to a target area where you want to deposit them and creating structures based on that. So that sort of gives you an intuition of what our limitations would be. The smallest particles that we can suspend would be the smallest feature size we can make. We've taken 3 nanometer particles and created structures that are 25, 30 nanometers in size. The way the process works is the closest analog that I can offer to you is a sort of a screen printing at nanoscale. So we start with a substrate. We create a pattern on it, depending on what you're trying to make, using traditional conventional lithography processes. So that would be the other limitation of our process. Whatever the lithography tool you have available, that's the pattern, the feature size you can create with the patterning, and that would be one limitation on our technology. So we start by creating a pattern that's a negative of what you're trying to make. Then we functionalize the surface to make it hydrophobic. And then we immerse it into a bath and then drive the particles using a few different physical force technologies that we have to create the structure that you're trying to make. So in the bottom half of the slides in front of you, you see a process fast fluidic, where we are using the concentration of material in a meniscus as we are pulling the substrate out of a liquid bath. And so essentially, the process speed is about 100 millimeter per minute.